Hello, everybody. My name is Rob. My handle is Utkanos, which means duckbill platypus in Russian. I know this is probably one of the only locations or conferences where I don't have to translate it for most people, but so BalCon has become one of my favorite cons, and I'm glad to come back here for a second year. This talk is about malware hunting and malware hunting techniques and processes. So I am the Director of Research Innovation on the research team at Threat Connect, and I'm actually, we are live with one of my colleagues, Cezanne Vahid, and he was unfortunately unable to make it to the conference, but he is here out in the Ethernets in the network. So without further ado, I will let Cezanne introduce himself.
Hello everyone. Like Rob said, my name is Cezanne, and I am a research intern for the research team at Threat Connect. And me and Rob have been working on this project for the past few months, and we're really excited to present it to you. And I hope we have a good presentation today.
Thanks, Cez. So, by the way, if you want to tweet during the talk, these are my Twitter handle and Threat Connect Twitter handle. So if you want to tweet stuff, @mention us, etc. So one of the basic problems that I want to solve with this project and with some of the processes that I've developed underneath this project is to help out small teams. So when you have an organization such as ours, we have about 9 researchers on our team, so we have a very small team. So if you have a small team, you need big tactics because you're not able to compete unless you work smart. So one of the things I've tried to do with this project is to allow our small team to compete at the weight level or the weight class of large teams. And so to do this, we have to fight smarter. And one of the goals with this specific project in malware hunting is to find malware faster. And if not find it the fastest, find it the next fastest. So be the very next in line to finding new malware. So my hypothesis is thus, this is a little bit long, but I'll read it, I'll kind of paraphrase it for you. So malicious binaries out there, various forms of malware, whether it's an exploit kit or ransomware or a Trojan of some type, many of them exploit a vulnerability. So vulnerabilities are assigned a CVE. And so my hypothesis is that basically looking at all of the different virus scanner companies that all contribute their information and their scanners to VirusTotal, or if you go out and get your own virus scanner bank or create your own using something like Plague Scanner, you'll have the ability to kind of leverage these large teams. So virus scanner companies, just off the top of my head, some like ESET or Bitdefender or Kaspersky or McAfee, they have large teams. They have much larger teams than our 9-person team. And so I have found a way to leverage those larger teams collectively to hunt malware and not necessarily find 0-day malware, but find 1-day malware. So basically piggyback on their ability to boil the ocean and find all of the 0-day malware that they can. And then I find it through this process almost immediately after they find it. So a couple of definitions that I want to cover first. So CVE is common vulnerabilities and exposures. It's a system for numbering vulnerabilities, so that a vulnerability that's in a specific piece of software is assigned a number, and that number is a CVE number. These CVE numbers are maintained and disclosed by a number of different organizations. So the organization that goes and discloses the vulnerabilities in the CVE There's a whole system for disclosing them. So this is US CERT, so that's the United States Computer Emergency Readiness Team. And this is run as a part of the Department of Homeland Security, DHS. And then the organization that maintains all of the CVEs in a database is the National Vulnerability Database, NVD. And this is maintained by the National Institute of Standards and Technology, or NIST. So past those definitions, I want to talk about the tools that I'm using to find the malware. So the tool that I'm using primarily is called Yara. And you may be familiar with Yara. It is a signature tool which basically looks at the static qualities of a file, any file. You can look at many different things. You can look at strings. You can use a regular expression to find certain, not necessarily a specific string, but a regular expression representation of a string. Additionally, if you use Yara rules in conjunction with VirusTotal, you can also hunt for certain tags and certain indexes that VirusTotal uses to categorize the malware that they have in their database. In addition to this, you can look at basically anything. You can have Yara Yara basically looks at a file and matches qualities that it finds in that file that match a specific signature or rule that you have written. So, and this is an example of one CVE. This is an Adobe Flash vulnerability. So this is CVE 2016-4249. It's a heap-based buffer overflow in Flash Player, such and such versions. And then it allows an attacker to execute arbitrary code via unspecified vectors. So these are the type of CVEs that I find important for this specific project. So I want to kind of back up a little bit and talk about the process that I developed that underlies the system that I'm talking about today. So back in February of this year, I spoke at the CTI Summit, the Cyber Threat Intelligence Summit in Virginia, and we talked about, a colleague and myself, Rich Barger, we talked about a Yara hunting process which automates looking at files that are deployed in files that are sent to VirusTotal. It is also used, if you want to, you could have this Yara hunting system deployed on your mail server if you're looking at attachments or any files that are coming in through email. If you have an inline network security monitoring tool such as Bro or Snort or any of these, you can use Yara to look at the files that these NSM systems find out on the wire from packet capture. Or if you have endpoint protection, and many endpoint protection products will, if there's something new, a new executable that it hasn't seen before, it will take that file and send it to a central server. So you can take the Yara hunting process that I've developed and put it on top of these systems which pull in malware from your enterprise, and then look at those malware looking for any of the qualities that you would put into a Yara signature. But one of the things that I added to this process is putting a confidence and a priority on each one of the rules, so that when you deploy the rules, you can, before you deploy the rules, kind of decide this specific rule is something that is more important than this specific rule, or this rule has a lot of false positives compared to this rule. And therefore, once you have confidence and priority on all of your rules, you can then arrange them in descending priority and confidence. And if you have a limited amount of automated malware analysis systems, you can take only the files that you find that are a highest priority for you, and you can sandbox and analyze them first using automated malware analysis systems. So this whole process is kind of captured here in this pair of swim lanes. So all of the Yara rules that my team uses, we keep them in a Git repository. because rules kind of look much like source code. So if you use the same source code repositories that programmers use to keep their source code, you can keep your rules much more organized. So all of these rules get updated in revision control. Then they get deployed to your hunting system, whether this is at VirusTotal or whether this is on your mail server attachments, or whether it's on your NSM system or endpoint protection. Then that system then uses that set of YAR rules to hunt for the files that you want to find in that pool of files. So then that will, if a rule matches a file, it will generate a notification. So then this notification prioritization system arranges the notifications in order and then downloads the files from the database if it was VirusTotal, or if you already have the files, you skip that step. And then they all get sent to the sandbox. I use many different sandboxes. One of my favorite is Cuckoo Sandbox, which is an open source project. Many of you have heard of it. And then all of the network indicators that you can extract from that particular piece of malware or file being detonated in the AMA, all of those network indicators you can then take with the file itself and upload those to a threat intelligence platform. So moving on, that's the underlying system that I use to kind of organize what we're talking about today. And just a little bit of information about what happened after my team began using this system. There was a 15% reduction in time to process and analyze a sample that was interesting. So over 1,500 samples. So this saved 300 hours. So 300 hours doesn't sound like that much of time over this amount 6 months or so, but 300 hours is a lot of time when you're looking at someone who's an analyst who was in the past doing a lot of manual moving around of information, and now the automation allows this person to do their job and analyze the malware itself. So we had a 30% increase in content production. And so this, as it says here, the analyst can reclaim that 300 hours and use it to do analysis rather than busy work. So, all right, now that that's sort of the backstory of the system that we built. So now let's talk about predictive CVE hunting. So this is a way to basically fight above our weight class, and with a small team of 9 people, we can go out and find malware that is new. We're not finding the malware that is zero-day malware, so we're not the people that found it first, but we're able to find it second, and we're able to find it very quickly within a 24-hour period. So this is the YAR rule template that we use. We'll be publishing the slides, so if you need to use this YAR rule, it will be available. So to explain it, you have the rule name at the top, and then the CVE variable here is a regular expression, and this is a nuance of the rule that I'll talk about later when we get into some of the special false positives that we found after we deployed the system. But this basically looks for the CVE number in text, in strings in the file. In addition to this, it also looks for tags in VirusTotal, and then also if the signature that the virus scanner engine replies with. So if you submit a file and scan it with Kaspersky, some of the virus scanner results that you get back actually have the CVE number in the result, meaning that the virus scanner engine has a signature that detects that particular file, and they already know that it's attacking that particular vulnerability. So, and then a little bit of that end part with new file and not tags, that's basically to clean up some of the complete false positives that I know are unnecessary and not interesting for the project. So this is a list of the vulnerabilities that are important for me. So if you think about it, there are many, many, many vulnerabilities that come out in many different systems, but I want to narrow the number of vulnerabilities that I look at just to ones that are, for the most part, operationalized in malware. So malware is going to exploit browser vulnerabilities, so Opera, Chrome, especially Internet Explorer, Firefox, and then operating system vulnerabilities. But I'm not so interested in all operating system vulnerabilities. I'm only interested in privilege escalation and then arbitrary code execution, so especially remote code execution. And then, of course, the usual set of offenders, as I like to call them, so Java, Flash, PDF, Silverlight, all of the things that you should turn off on your browser at all times, I think. And then Office documents, so PowerPoint, Word, and Excel documents. And then also we've begun applying this system to mobile malware. But I wanted to focus only on kind of the more popular mobile systems, so iOS and Android vulnerabilities. So has this worked? I want to show you some of the hunting system in action, and I want to start with the failures. So I want to show you some of the things that happened when it didn't work. And I'll talk about why it didn't work and then how we improved the system after reviewing why this thing didn't work. So the first near miss that we had was last year. So this is CVE 2015-0336. And it was operationalized by Nuclear Exploit Kit on March 19th of 2015. This is an arbitrary code execution in Adobe Flash. And the reason why we missed it was the rules at that time, this was last year, the rules were only looking for CVE numbers in AV scanner results. So at that time, we weren't looking at all the different things that you can look at with a YAR rule. And so the AV scanner results didn't actually have this CVE in it. But a researcher, and if anyone here does malware research, you're probably familiar with Caffeine. So Caffeine found some of the first samples and then uploaded them to VirusTotal, and then he tagged them with this particular CVE, and because he was the one that tagged them with the CVE, it basically bypassed the YAR rules that we had written. And so we learned from this, and back a couple of slides, it has tag includes blah, 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 and tag contains CVE number, and so we added this to the template for the rules that we're generating. Another one was more recent. So this near miss, so this entire project has been going on for maybe a year and a half, but I didn't have the resources, the manpower to actually continue the project. The person who was working on our team left our company. And so for a period of time, we had shut down the whole system. And then when Cezanne came on the team, we had the manpower to bring the system back up. But the system basically, and this was a few days, literally a few days before Cezanne became part of the project. And so, the intern was still being trained on how to use everything and how this whole thing works. And so we missed this because the system was actually, at that time, mothballed. But what we did was we went back and then deployed all of the missing YAR rules that had basically all of the CVs that had come out since we mothballed the project. And then we had a flood of stuff that we could have found if the system had been running the entire time. So I want to move on to some of the ones that we hit on. And so we found CVE 2015-1641. So this is a Microsoft Office memory corruption vulnerability. So this is a vulnerability that is used in Office documents, rich text file. And it allows remote attackers arbitrary code execution via a crafted RTF document. And one thing that's interesting is after we deployed the rule for this, we found this at first, and then now literally we are swimming in alerts for rich text files that exploit this particular vulnerability. We're thinking about creating a feed of just these malware files. The second one is CVE 2015-5122. So this is a use after free. This is another Adobe Flash Player vulnerability. So use after free vulnerability in the display object class in ActionScript 3. So this is another one that we found second, basically. We didn't find it first. But again, this is one that is deployed a lot in many exploit kits. And similarly, the next one, CVE 2015-5119, is another use after free in the byte array. Again, turn Flash off. Don't use Flash. I hate it. I hate it. This is another one that we're basically now swimming in malware that exploits this vulnerability. So what I wanted to talk about next, and these are false-ish positives. So they're not true false positives because we found something that was interesting to us, but it wasn't malware that was exploiting the vulnerability. So there's two categories that we found. First of all, is there are many vulnerabilities that are exploited in the wild, but they're not exploited by malware. They're exploited, they might be part of, they might be part of an exploit that's used like Metasploit or something that's used as a payload, this sort of thing, but they're not actually weaponized in malware. And so we found a few files that were payloads. So some people will submit their payload to VirusTotal. And so we found a lot of payloads that people were submitting that exploited a particular vulnerability, but the payload was not actually, malware in the traditional sense that we think of it as like, a Trojan or a malicious document, but it was still exploiting this particular vulnerability. And what we did was at this point we went back and looked at all of the exploit DB and Metasploit's exploit database and all of them, and kind of reviewed the rules that we had created and deprioritized a lot of the ones that have been found in the wild, basically in these different databases. But they're still there, so we're still hunting for them. So occasionally we will find some either pen tester, or possibly an adversary's payload, and then we'll be able to analyze that and kind of kind of figure out like where it's calling back to and things like that. Another thing that we've added, which is kind of very interesting, and this is if you remember in the YAR rule we just looked at, there's a variable CVE with the regex, the regular expression for looking for CVE numbers. So we found that a lot of people will submit text documents that are not malicious, but talk about things that are interesting for us. So the things that people submit to VirusTotal are not always going to be malware files. They might be a text document. They might be an Excel file that's not malicious, but is talking about something that we would be interested in, specifically in the context of a CVE. So we've kind of expanded our net to look for things that are not necessarily malware, but also documents that people submit that are talking about CVE. So we're looking for text files. So these two I consider they're false-ish positives. The original hypothesis of our system didn't include these, so they're basically false positives. But now we know that these are things that are interesting for us to look at. So what I want to do is turn the discussion over to Cez. And he's going to talk about some of the things that he's been working on in his part of the project. So, the basic components of the project we put together, and a lot of this was, before he joined the project, a lot of it was very manual. And so he has been working on automating some of the things of the project, automate all the things. So he's been working on automating components of the project that basically he was working on, and so he's kind of automating his own pain away because he was the one that had to do a lot of the manual stuff. So I'm going to turn it over to Cez and move to the first slide for you.
Are we on automate all the things?
Yep, you're on 23.
Okay, cool. Hello, everyone. Thank you, Rob, for going over all that. That's really cool. So as I mentioned, my part is to automate the rule generation and kind of the hunting process. This part is going to be mostly review of what Rob has been discussing, except we're going to focus a little bit more on the automation side of things. So if we can we go to the next slide? 24?
Yep.
Okay, so a little back. So initially, we created the YAR rules by manually going through the US CERT and NVD vulnerability summaries and formatting them into YAR rules. But those days are over. We have been making great progress in automating this, and I will explain how this works. So as Rob mentioned, our two sources are for CVEs are US CERT and NVD. And now we have a Python script that grabs the CVE identifiers released in the feeds through RSS, and we can generate YAR rules automatically through RSS and just feed parsing. So we take the identifier, which is the CVE number 2016 blah blah blah, and we give it a name. Usually the names are attached to the CVs with the release of their summaries. And we generate a rule. And I can show you an example in the next slide, which is, are we on 25?
Yep. 26.
Yep. Or 20...
Oh, you want to... Sorry, 25. Sorry.
Yeah, cool. So here's an example of a Linux kernel vulnerability that was released by both NVD and US CERT in their bulletin summaries. And we grab this information and we parse it. We take the identifier, which is that number, 2016-5344, and the name, the Linux kernel vulnerability. And if you go to the next slide to 26, we have an example of a YAR rule that's formed from this example. So I'll give you guys a second look at that. And so as you can see, just the rule name, we have the tags that contain the CVE identifier. And then this rule, these rules are uploaded to VT, where they stay engaged and basically they stay active and waiting to be triggered by malware. This process is now automated, and now we can have this system running on a server, and we don't have any no human interaction, no interference. This is just running and automatically grabs the CVs and creates rules and uploads them to VT, and that saves a lot of time. So we are going to continue on to processing the hits. Slide 27.
Yep. We're there.
Cool. So previously, we would get email notifications when a rule is triggered. This required an analyst to go and manually download the sample and upload to, Joe's Sandbox or Cuckoo and whatnot, do basic analysis. So we wanted to automate this process as well. So what we would do is have a bot listening for VT notifications when a rule is hit, and then download the sample if it meets prioritization. The bot then uploads the sample to some sort of sandbox like a Joe's or Cuckoo, and basically grabs any further IOCs such as network indicators or drop files. And now the analyst has something to work with without having to do any of that themselves. So now they can concentrate on what they do best, the human aspect of analysis and doing further research with reverse engineering and whatnot. So I think that should be it for the automation process. I hope that clears it up for everyone. And yeah, I'll pass it back to Rob.
Cool. Thanks, Cez. So, by the way, so Cez has been doing a lot of the heavy lifting. So he's been doing a lot of the programming in Python, and thank you. Thanks, Cez. You're awesome.
Thanks, Rob.
So, and one of the things I wanted to go back to with this is the idea that you're basically piggybacking on other organizations. So I think this is a really important point to take home, is that even if you don't have the resources or the budget, you can be crafty and go and, if you think hard enough, you can find a way that you can basically use other people's resources and leverage them in your own way and be able to, basically hunt for things, in this particular example, hunt for malware through other people's hunting processes. So what we've done here is we've taken the processes that, and I'm going to probably get called out on this number being incorrect, but I think it's around 52 or so, 52 or so virus scanner engines that are available in VirusTotal. You can have as many virus scanner engines as you want if you want to do this on your own outside of VirusTotal, but you're basically taking the time that you put into the project and your team, and then not wasting time looking for stuff yourself. You're basically allowing yourself to piggyback on 52 different teams that are all out there doing very similar things to what we're doing, which is finding new malware and reviewing it and analyzing it and reverse engineering it. But you're basically taking, you're basically having your small team and then multiplying that by 52. And so you've got this massive team, very wide net, all over the world. And, the AV scanner engines out there come from all over the world. I know that ESET is from, I think, Slovakia. I know Bitdefender is Romania. Kaspersky is Russia. McAfee, Symantec, they're both from the US. So you've got you have a very wide reach when you leverage this type of network, and you can find files that are not necessarily ones that you would normally find attacking your own region or your own industrial vertical. So you'll find stuff that might actually be targeting a different country. You could find stuff that's targeting a different type of business than you find. And so you're able to find things and then operationalize like the intelligence that you can gather from that and use it to protect your organization. So I wanted to move on and kind of ask, does anyone have any questions on the stuff we've talked about so far? Yes. And Cez is live too, so if you have a question for him as well.
Hi, I'm doing this stuff for just for hobby, only manually. You mentioned caffeine and malware must die and all these blogs. Where do you find that amount of malware? Where do you stream files from? I mean, I can just pick 2 files a day, when I want to try, but you need thousands of files per day, right?
Correct. So the question was, if you have access to a lot of the blogs like Caffeine and other malware researchers, where do you find access to malware files in volume? He was saying that he has access to maybe a few files and stuff like that, but where do you find thousands of files to do this? So there are a few techniques, and if anyone was here last year at Balkan, I gave a talk on spam honeypots. And so running your own spam honeypots is a very good way for collection of new malware in volume. Basically, the amount of resources you want to devote to VMs running, open mail servers that'll receive malware from anywhere. The amount of resources that you'll devote to the number of VMs that you can deploy, that's X whatever. That's the amount of malware that you can collect. So you can collect a lot of malware that way. There are other. So that's malware that's based or distributed via email. There's a lot of other types of malware out there. There's botnets that will actually connect and deliver a payload over a particular port. So Dianea and other types of honeypots, they're a different style of honeypot, but you would want to deploy that type of honeypot. And those are mostly, I think they're kind of medium or low interaction honeypots. What you'd want to do in addition to this is have a high interaction honeypot, which basically emulates an entire operating system or a service at least. and then because it emulates that particular service or operating system, an attacker will connect to that service and basically give you a payload of some kind. So that's another method of collection. Also, there are a lot of public sandboxes. So some of my favorites, Malwar, M-A-L-W-R. This is a public sandbox that's based on Cuckoo. Some of the authors of Cuckoo run this, and it does have a login. You'd have to apply for an account, but the account is free. And some of the files, not all of the files that you find on Malwar, but some of the files, if the person who submitted the file, checks the box saying share, if you have an account on there, you can download that particular file. Another one of my favorites. So Jan Miller runs a company called Payload Security, and they have a sandbox called VXStream. And they have, it's a commercial product, but at the same time they do something like what Malwar does with Cuckoo. And they have a public sandbox where anyone can submit files to it. And again, it works in a similar way where you can get a free account on the system. And then if you have an account on the system, you can download malware files that have been submitted and shared, of course. Also, and I can't say how much I love that particular system and Jan Miller and that whole system, because if you have an account, you not only get access to the malware file itself, you can also download the packet capture. So you can download the PCAP from the malware running in the sandbox. And I've had another talk that I've been giving at other conferences about open source malware labs. And so I can tell you, if you have access to the PCAP as opposed to the output that you get from a sandbox, you get more. There's sort of I forget what the term my friend used, but there's information in the PCAP that you can get out of it that a sandbox may not have been able to interpret using the software that it had for PCAP analysis. So, for example, Cuckoo, I believe, uses DPKT, and I'm not sure what VXStream uses for packet analysis, but in my lab, I use Bro for packet analysis, and Bro finds, Bro can find things that maybe the sandbox didn't, just didn't detect. Not that it wasn't, maybe it didn't detect a particular protocol, or maybe there was just some failure during that sandbox session and it didn't find a particular IP address. There's many reasons for it, but the packet capture, the PCAP, is sort of ground truth it's ground truth when you're talking about the communication of the malware. And so if you go back and analyze the PCAP itself, you can get much, much more. And also, where I was going with this is, if you get the PCAPs from that hybrid analysis, you can actually get more malware samples from the packet capture from carving files out of it that you can then analyze further. So you'll have many malware families will have staged attacks. So the first stage is maybe a weaponized document, and then the second stage is a dropper. Second stage might be Pony or something like this, and then a third stage might be Vautrac, and there's different stages. But if you're looking at just if you submit maybe the first stage to a sandbox, you don't always get the entire picture of what's happening with the further stages. So it's always important to take those further stages, maybe carving them from the packet capture, maybe looking at what the download URL is and downloading a copy of it yourself, and then sandboxing those separately from the first or second or early stages of malware. Yes.
Mind explaining CVE 2015-1641? It's related to RTF, rich text file documents, right?
Yeah, let me
Can
go
you
back.
explain how the arbitrary code executes? How does it work? Is that weaponized document?
Yes. So, and honestly, I mean, the volume of vulnerabilities and exploits that are out there, I don't focus on the specifics of actually how that particular exploit works. So, I'm casting a wide net and looking at all the vulnerabilities and kind of looking at which ones I can match up with which malware families and which ones are being used in which exploit kits. You could spend your entire life diving deep into each one of these exploits. So I don't know how this one works technically, but I could answer that for you later. I could find out.
Yeah, it would be nice. Yeah, thanks.
But I know specifically how it's how it's used is your typical rich text file attached to an email saying this is an invoice from your Amazon account. Please open this and then check.
They would basically distribute the RTF file, right? The
Right.
RTF document. You would have to.
Yeah, it's
basically,
spam based.
Yeah, you would get a kind of form on PDF. You might not recognize it sometimes. It might be like the original sender. Sometimes you would open the document, nothing would happen still. But when you fill the form, save the document, then the arbitrary code might be executed.
Correct. So
Right?
there's a number. So he was asking, you could fill a form out in a PDF, for example, right? And then the exploit would run when the PDF is saved. Yes, that's one way. But so there's basically when you're talking about malware that is like malware spam, that's an attachment. There's kind of two categories, I would say. So there's malware spam that uses a exploit, which is what we're talking about here. Those documents typically don't have any legitimate information to look at. You open it, exploit runs, the shell code runs, and then something bad happens. You're possibly the software that you're using to view the document will crash. If the exploit is a very good one, it won't crash, and then you won't even notice. But in these situations, the document itself doesn't typically have what I would call like bait in it. But there's a whole other category of malware, which is a lot of it would be VB script, macros and stuff like this. Many of those will have some sort of bait information in it. So and those are more used for targeted attacks. So the adversary will go and find a document that you might find interesting. They'll typically strip out all the other pages. So it's just they'll take the first page and then weaponize it with VB code or whatever sort of other code they're using. If it's a PDF, maybe JavaScript. But at that point, what they're doing is there's like a small layer of like social engineering there, where they're trying to trick you into opening it because you think it's going to be interesting, and then the malware runs and then something happens. But those typically don't exploit. Those don't exploit a vulnerability they exploit a vulnerability in the human's brain rather than an exploit in the technology underlying the document viewer.
True. Thanks.
Any other questions? Yep. Oh, tough question. Inbound.
So obviously there's a very active darknet market for what some call APTs or just not your garden variety, like banking Trojans and things like that. And I'm just curious, as somebody who gets to kind of see the world behind the veil, so to speak, what kind of crossover, what kind of metrics there are in terms of monitoring darknet markets and how many of these casually deployed kind of wide-netted exploits you see from darknet metrics, and what the visibility is like. Like, I mean, if you can even give like a garden, like a general ballpark percentage of like the number of like, you know, I mean, do you see a lot of poison ivy? Do you see a lot of dark comet? You know?
So honestly, it has changed literally in the past like 4 months or so. So he was asking, you know, what is the what are the ratios of the things that I'm seeing, kind of CVE based, like to what I see coming out of darknet and what I see coming out of like the bad side of the world.
Right.
So one of the things that happened recently was there was a big takedown in Russia with a lot of cyber criminals. And so I don't know whether, you know, this corresponds, you know, directly, but I know that a bunch of exploit kits went dark. Lockheed disappeared for a while, came back strong. So, you know, whoever's behind that didn't stay in jail for long. But I would say that things transitioned from being, you know, and I'm not going to go. I'm going to just go for some ballpark because I don't want to get caught saying, oh, 55%. You know, actually 75% of statistics are made up on the spot. So, but I would say there were more banking Trojans before that event, and now a lot of the adversaries and a lot of like the exploit kits have begun delivering more ransomware. Ransomware is the new bad thing. You know, that is the new popular thing to deliver. And I think one of the reasons for that is a banking Trojan requires a secondary money exfiltration system. So once you've captured a login for someone's online banking, or if you've captured a credit card number, then what do you do with it? You need to actually do something else with it to get money out of it. But with ransomware, you've cut out that money exfiltration middleman, where the client or victim, the client is sending you the money directly. So I think that it's basically it's a logical progression in like the concepts of cybercrime.
Has that like correlated with like a decrease in some of the more advanced kits being for sale, or? So
I would say it has. So when you say the advanced things being for sale, so one thing that I found interesting is there's a lot more kits for macros being sold, right? Which I wouldn't call that advanced from my perspective. You know, as a reverse engineer, I wouldn't call it advanced, but from adversary user perspective, it's much more effective. So you could consider it more advanced in its effectiveness. So the thing is, a lot of the exploit kits, the malware itself, I've seen more of the malware, like a Trojan, that sort of thing, like them, state-sponsored actors, stuff like that, still exploiting, some of the more obscure vulnerabilities and some of the common ones. But the day-to-day delivery of malware starts with an exploit kit, which is typically, going after PDF or Flash or Silverlight or Java. Actually, not so much. Java actually has kind of fallen off, and I would say I thank Google for that, because they said, we're not going to have any more plugins that are NP API. Everything has to be PP API. And then Oracle said, we're not going to make a PP API Java plugin, and everyone went, awesome, perfect. But yeah, so I haven't seen Java, but the exploit kit layer, the first layer of delivery, definitely, almost entirely relies on vulnerabilities. But the next layer payload, the payload that it's delivering, doesn't necessarily these days rely on an exploit or vulnerability.
Awesome.
Looks like we have about 5 minutes left. Any more questions? All right, so I'm going to jump back to the slide I was on before. All right, so if anyone is going to be around for different things and fun stuff in the future, I will be at DerbyCon in, that's like 2 weeks? Wow. So yeah, I'll be at DerbyCon in 2 weeks. This year I won't be speaking at DerbyCon, I will just be hanging out. So come and hang out there with me. And then after that, early next month, I'm going to be at Virus Bulletin in Denver. I'll be speaking about open source malware labs. And then in Toronto at Sector, which will be, that's actually like 2 weeks after that. So I'll be in Toronto giving another talk about Cuckoo, Bro, Volatility, and Thug. So come check me out if you're in any of those locations. And that's it. So thank you. Thanks for coming. And
Thanks.
thanks, Cez. Let's give Cez a round of applause.
Thank you.